All right, here we go. 4-2. Using graphs to relate two quantities. After this lesson, I will be able to identify and represent patterns that describe linear functions. Here we go. Stop. Make sure your volume's on. You got to listen. All right, here we go. Billy works in the summer mowing lawns. He profits $25 per lawn that he mows. How much will he have if he mows 0 lawns? How about 1 lawn, 2 lawns, 20 lawns? Use a table. Okay, and then we'll get to this stuff here in a second. So he mows and he gets $20 a lawn. Well, if he didn't mow any lawns, he would have 0. All right. So let's take a look at a table. We'll start plugging them in the table. So number of lawns here, money. The money depends on the lawns. So this is my independent variable. This is my dependent variable. 0 lawns tells me $0. 0 times how much I get paid is still 0. All right, 1 lawn. Well, if I mow 1 lawn, I get $25 a lawn. That's 1 times 25. That's $25. 2 lawns, 2 times 25. That's $50. 20 lawns, well, that's 20 times 25. That's $500. That's pretty easy. All right. In the situation above, the amount of money that Billy has depends on the number of lawns he mows. The more lawns, the more money. All right. So the amount of money I have depends on how many lawns I do. In the relationship between variables, the dependent variable, in this case the amount of money, changes in response to another variable called the independent variable. All right? The number of lawns that I mow doesn't depend on how much money I have. The amount of money I have depends on how many lawns I mow. Okay? So this is my dependent variable. This is my independent variable. Values of the independent variable are called the inputs. All right? And then the values of the dependent variable are called the outputs. All right? Cool. So we'll see all those things again here in a second. All right, our understanding. The value of one variable may be uniquely determined by the value of another variable. Such relationships may be represented using tables, words, equations, sets of ordered pairs, and graphs. Okay? Uniquely means you get one answer. Diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Perimeter, distance around. Represent this relationship using a table, words, an equation, and a graph. All right, so look at this rectangle. It's a rectangle, so if this is 1, this is 1. If this is 6, that's 6, right? If you add up all the sides, not just these 2 sides, all 4 sides, perimeter. Well, the variables are the perimeter, and the perimeter depends on how many rectangles. Look, the perimeter is going to change because I'm getting a bigger figure. All right? So the perimeter depends on the rectangles. That means the perimeter is the dependent variable. That's the y. The number of rectangles is the independent variable. That's the x. When I go to make my table or I go to write some points. Okay, so if I make my table here, the number of rectangles, or the x, the perimeter, or the y, and then I'll just list them as some ordered pairs as some points. So 1 rectangle, the perimeter was 14. 2 times 1, because there's a 1, there's a 1. So there's 2 1s, and there's 2 6s. There's this side and that side. Total, 14. This would be 2 plus 12, which is 14. So when my x was 1, my y was 14. 1, comma, 14. All right? Look here. 2 rectangles. Well, now I got a 2 and another 2. So I have 2 2s. I still have 2 6s. So this didn't change. This is the only thing that changed. I got 2 2s and I got 2 6s. Total, 16. So when x is 2, y is 16. There's my point. All right, 3. So I got 3, another 3. So now I got 2 3s. 2 3s now. I still have 2 6s for the sides. Total 18. So 3, comma, 18. And then number 4, I got 4, another 4. I got a 6 and a 6. So I got 2 4s, I got 2 6s, that makes 20. All right, so 4, comma, 20. All right, awesome. So remember, perimeter is easy to find, just add up all the sides. All right, so in words, well, you multiply the number of rectangles by 2. All right. So whatever the number of rectangles was, I multiplied by 2, and that gave me the top and the bottom. Then add 2 times 6, or 12 basically, which is the length of both of the sides. So I always had 6 and another 6, 6 and another 6, 6 and another 6 for those outsides there. All right, for my equation, well, the perimeter is equal to 2 times the number of rectangles plus 12. All right, and then if you wanted it in symbols, y equals 2x plus 12. Because remember, x was the number of rectangles, y was the perimeter. Perimeter equals 2 times the number of rectangles plus 12. This is your 12 right here. 12, 12, 12, 12. So that was consistent. This is just 2 times the number of rectangles. 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 Okay? Cool. Alright, so the last thing they want me to do is draw a graph of it. So there's a fancy graph. And now once I have these points, I just have to plot the points. So x, y. X is 1, y is 14. Notice on the graph here, I didn't want to make a gigantic graph, so I counted by 4s going up. 4, 8, 12, 16, 20, 24. So let's fill those numbers in between. So 4, 12, and 20. It'll help us. So on the bottom was the number of rectangles, and on the left side is the perimeter. X's, Y's. So now you just need your points. 1, 14. So 1 rectangle, 14. Remember, this is 12. So 14 would be in the middle right there. 2, 16. 2, 16. Right there. 3, 18. 3 rectangles. 18 would be right there. And then 4, 20. Well, 20 is right here. Okay? So there's the points. So it's easy enough. Once you get a table, it's easy to plot the points. Put them on the graph. Great. Okay, another example. Diagram below, what's the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Okay. So we got some triangles with the pictures. 2 triangles, here's your picture. 3 triangles, here's your picture. 4 triangles, here's your picture. So in all the pictures, the 3 and the 3 stays the same. Right? You're just adding a certain number of 4s into your picture. So your variables, the perimeter, distance around, depends on the number of triangles. So the perimeter is the dependent variable because he depends on the number of triangles. So he's the y. And the number of triangles is the independent variable, that's the x. Okay? So in your table, 1 triangle means I had a perimeter of 10. I got 1 4, and I got 2 3s. 10. 1, 10. 2 triangles. Here's your picture. Now I got 2 4s. I still have 2 3s. So this part's not changing. 14. Number 3. Now I got 1, 2, 3 4s, but I still got 2 3s. Total 18. And then 4. Now I got 1, 2, 3, 4 4s, and I still got 2 3s. Total 22. 4, 22. All right, hopefully that makes sense. And you're processing, not just copying on the table. All right, so in words, if I multiply the number of triangles by 4, that's what I did right here. 1 triangle times 4. 2 triangles times 4. 3 times 4. 4 triangles times 4. And then I'm always adding the same 6 each time. Add to that 3 times 2, which is 6, which is the length of the bottom of the sides. So the 3s and the 3s were always these sides. The 4s told me the top and the bottom. Okay? How many 4s? Well, that depended on how many triangles I have. Cool. So my equation would be y equals 4 times the number of triangles plus 6. Or in symbols, y equals 4x plus 6. Great. Graph, same idea here, going by 4s here, so make that 4, 12, 20 to fill in those other numbers. And then just plot your points. 110, 214, 318, 422. Good. Make sure you label your axes. Dependent variable, perimeter. Independent variable, number of triangles. Great. Okay. You can describe the previous relationship by saying that the perimeter is a function, meaning it's the perimeter changed based on the number of triangles. So it's a function of the number of triangles. A function is a relationship that pairs each input value with a unique or exactly one output value. So when I did one triangle, I got 10. I wouldn't all of a sudden do one triangle and get a different number. 1 will always go with 10 for that problem. 2 will always go with 14. Okay? Here's how I kind of like to think about a function, is that when I put something in my independent variable, I get something out. Alright? And I get the same thing out each time in my machine. So when I put in a 1, whoop, and he goes into this machine, he spits out a 10. And for this problem, he will always spit out a 10. I wouldn't all of a sudden put in a 1 and get an 11. Alright? So that's what it means to be a function. A function is a relationship that pairs each input with exactly one output. Cool. We have seen that one way to represent a function was with a graph. A linear function is a function whose graph is a line. All right, linear, line. Notice there's the word right there. So a linear function is a line. All right, let's take a look at linear function. So, table shows the relationship between number of photos and the amount of memory in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. Okay, so they gave me the table. All right, so let's see what's going on. So your variables are the memory remaining and the number of photos. So how much memory you have depends on how many photos you take. All right, so the memory is the dependent variable. The number of photos are the independent variable. Right, your x's are your independents. Your y's are your dependents. Okay, great. So look at the table each time. From 0 to 1 is plus 1. From 1 to 2 is also plus 1. And from 2 to 3 is also plus 1. So it's consistency in your changing of your x's in this part of the table. Okay? Now look over at the y's. Those change consistently also. Though not the same as though not the same as the x's, they are still consistent. -3, -3, -3. Okay? So that tells me that it's going to be a linear function. As long as I have consistent change in the x's and the y's, I'm going to get a linear function. Okay? If this was plus 1, plus 1, plus 1, and then over here was -3, -3, -5, well, then it won't work. Okay? So good. I have no idea what that was. All right. So in words, the camera starts at 0 with 512 megabytes of memory. Each picture takes up 3 megabytes of memory. To find the amount of memory remaining, multiply the number of photos times 3 and subtract that from 512. So each one takes up 3. So I start with 512 minus 3 for one picture. Minus 3 more for another picture. Minus 3 more for another picture. Okay? So the equation, the memory is 512 minus 3 times the number of photos. So y equals 512 minus 3x. All right, here's your graph real quick. All right, notice what's going on in the graph. This little squiggly says that we didn't use every number there, right? So we're just using part of the graph. So 0, 5, 12. So 0, 5, 12. 1, 509. So notice it goes 1, 2, 3, 4. 1, 509. 2, 506. And 3, 503. Notice the points line up. which we knew they would because I get a linear function here because of consistency in my x's and consistency in my y's. Look at the points. They're in a nice pretty line. Okay? That's it. I'll see you next time. Peace.